In this video, I'm going to be talking a little bit more about some radical review, and these are all going to be involving fractions, where we're going to have to take the radical out of the denominator. As mathematicians, we don't like the radical being in the denominator. So what you want to notice on the first one is you want to notice that what you can do is you can split that radical over the numerator and denominator, which then allows me to take the square root of 49, which is 7, the square root of 36, which is 6. So that was our easy example. Okay, so the next one, we have a radical in the denominator. We need to get that radical out of the denominator. So how we do that is we multiply by root 3 over root 3. Remember, this is like saying 1. So I'm not changing my number at all, because root 3 over root 3 is 1. So I take and I multiply 5 times root 3. I can't multiply the 5 and the 3 because the 5 is outside the radical. Now I can multiply those root 3 times root 3 and get square root of 9, which then simplifies the square root of 9 is 3. If you can go right to simplifying this to root 3 times root 3 is 3, if you can go from this step down here, I'm okay with that, as long as you see that. Okay, the next one, my recommendation, and I might be alone in this in the math department, but my recommendation is that you simplify your radical in your denominator first. So basically, if you can pull a perfect square out of this, so remember I write this as 4 times by 3, and then simplify from there. So I have 7, 4 breaks out and becomes a 2 outside, square root of 3. Now I can multiply. Now I have a much easier number that I can multiply by. So I can only multiply by root 3 over root 3, instead of multiplying by that root 12, and then I would have to do a lot more simplifying. So I personally think it's easiest if we simplify first. So we have 7 times root 3 on the top. We have a 2. Root 3 times root 3 ends up just being a 3. So this all simplifies to 7 root 3 over 6. Now you want to try and simplify anything that's outside of the radical. We can't simplify that root 3 and the 6. The root 3 is kind of like locked in a little house in that radical. So I can't simplify that root 3 with anything that's not also in a radical. I can't simplify the 7 and the 6 at all. So this is our complete answer. Okay. Square root of 54 over square root of 125. I was doing these examples beforehand and I did some math incorrectly, so I'm glad that I double checked this one. So again, what I recommend, and I'm going to kind of do it up here, is we write it as square root of 54 over square root of 125 and simplify from there. So 54, the largest perfect square that goes into 54 is 9 times by 6. Square root of 125 is 25. Always check if a number ends in a 0 or a 5. Always check if 25 goes in. That's your first easiest one. That's just my little side note. 25 times by 5. When I did this earlier, I thought it was 3. Rookie mistake. So then this ends up equaling the 9 comes out of my radical and becomes a 3 underneath my radical I still have a 6. Then I have 25. Square root of 25 is a 5. And then I have still a 5 left underneath. Now that's a lot. Now it's a lot easier for me to multiply by a number. Okay, if I multiplied 125 times 54, that's a lot. I have to do all that work without a calculator. That's really, really challenging. So now all I have to multiply by is root 5 over root 5. And that's a lot easier for me to do in my head because I know I can multiply the 6 times the 5 and get a root 30. 5 is there. And then I have root 5 times root 5. Well, that's also a 5. So 3 root 30, 5 times 5 is 25. Again, you want to see if the 3 and the 25 have any numbers that cancel. They don't. So you're done with this answer. I can't cancel something that's underneath a radical with something that's not underneath a radical. Thank you for watching my radical review.